In today's video, let's understand Root System Imbalance model. At a system level, shop floor performance depends on the balance between four interacting domains: heat generation to airflow to energy consumption to human performance. If any one domain becomes misaligned, the others begin compensating. Additional equipment is added to offset weaknesses elsewhere. Energy consumption rises, operational complexity increases, and yet the overall outcome, comfort, stability, productivity, remains largely unchanged. Now let's understand the main components of the Root System Imbalance 1. Heat generation imbalance. Heat generation often exceeds the facility's ability to remove it efficiently. Common contributors include process heat from machines, presses, furnaces, ovens, electrical losses from motors, drives, and transformers, lighting heat, inefficient HVAC equipment, fans and air movers converting electrical energy to heat, human metabolic heat, trapped heat due to poor roof insulation or ventilation. When heat generation grows unchecked, cooling systems are forced into continuous compensation. 2. Airflow imbalance. Air is the primary medium that transports heat away from occupied zones. Airflow imbalance occurs when supply and exhaust paths are poorly aligned. Air is trapped behind machines or in layout pockets. Fans create turbulence rather than directional flow. Roof level heat remains trapped due to poor exhaust placement. When airflow is ineffective and cooling systems remove less heat than expected, this leads to increasing cooling demand without proportional comfort improvement. 3. Energy flow imbalance. Energy imbalance occurs when multiple systems compensate for each other's inefficiencies. Typical cascade pattern looks like this. Process inefficiency to more heat, to cooling struggles, to more fans, and cooling added to electrical load increases to HVAC load, and runtime increases to peak demand rises. The result is escalating energy intensity without improved outcomes. 4. Human performance imbalance. Human productivity is the most sensitive variable in the system. Thermal discomfort leads to reduced endurance, slower reaction time, increased fatigue, higher error rates. Machines may operate normally, but human performance quietly declines, limiting overall plant productivity. The root system imbalance model. So, a root system imbalance occurs when the fundamental variables governing the shop floor environment, heat generation, airflow behavior, energy use, and human performance are not aligned. Instead of operating in equilibrium, systems begin compensating for one another. In such situations, the plant is not failing due to a lack of equipment. It is working harder than necessary to maintain the same operating condition. In our follow-up video in part 2, let's understand how to evaluate and correct this root system imbalance on the shop floor. The link to the part 2 video is at the end of this video and also in the description. If this perspective helps you think differently about your factory, then hit the like button, subscribe to the channel, and share with your team. 5-star technologies, creating productive and efficient shop floors.